Smart factory solutions for any mix, any volume. Total integrated solutions, allowing you to focus on your business while we manage your production challenges.
Welcome to the MIRTEC booth here at IPC Apex. I'm delighted to be joined by my old friend Brian D'Amico. He's the President of the Americas. Welcome, Brian.
It's always a pleasure to see you, Trevor.
Well, you know, it is a pleasure because we've got some really superb technology and software to take a look at today. Let's start with this machine behind us, the MV6 Omni. It's fitted with a tri-sensor or tri-view system. Can you explain a little bit about what that is?
Okay, well, MIRTEC, we pioneered what's called digital multi-frequency Moire. What that has is two different frequencies, and those two frequencies are used to characterize devices that are 0 to 5 millimeters tall. Well, the industry ain't that perfect, right? There's some taller devices as well, and as boards get more and more dense, the taller devices are closer to the smaller devices. So what we did was we now configured the systems with what's called the digital tri-frequency Moire. So that's kind of an industry first. What this allows us to do is each one of our projectors is capable of projecting up to 3 frequencies, which allows us to characterize from any angle from 0 to 25 millimeters tall.
Okay, so it's like having, it can go like in 3 different directions if you like, so it catches the component.
Basically, it's not so much the directions, because when you're talking about frequencies, it's a frequency pattern actually that we're putting out. So what we're talking about is basically a line pattern that we're using to characterize devices. The closer the lines are together, the smaller the device is that you can, the maximum size that you can characterize with that line pattern. But then as you start expanding that line pattern, you can start characterizing larger devices. So we basically have low, medium, and high frequency. So each one of the projectors is capable of projecting low, medium, high frequency. So on our 4 projection system, we're capturing 48 images, which is a lot of data. Yeah. Now we did just introduce, it's a prototype system, but we just introduced what's called the OmniVision 2.0 head, right? We always want to be the most technologically advanced company out there, right? This machine here, quite frankly, blows the doors off of everyone else. I will tell you right now, it is the highest spec system in the world because this machine has 8 projectors, 3 frequencies per projector. We can capture up to 96 images, which is a lot of data for characterizing a PCB.
Incredible. That must need a lot of power to crunch that data.
Yeah, it does. Yeah, it does. A lot of power. The lights may dim a bit, but it works very, very well.
But it does work. There you go. There you go. Okay, so we're also, the other thing we're standing in front of here is your INTELLI-PRO system, which is a brand new system for basically automatically teaching boards. Very exciting. Tell us about it.
Okay, INTELLI-PRO, so it's actually intelligent programming. It's actually our automatic program generation software. And what this allows us to do is to take Gerber information, marry it with Centroid information. From there, we basically program the machine or program the PCB automatically. Now, it is a prototype system. It's going to be available probably 3rd quarter of this year. But what this allows us to do is to minimize programming time. So once you're able to program the board, from there you're debugging. So just to give you a demonstration of how this works, we do have our demonstration board on here. There's probably 20 different types of components. So what we're going to do is we have right now the automatic program generation software. Let's turn that on. So this is using what's called ATT, which is our standard programming software. We bring in the XML file that we've gotten from the Gerber information. At this point here, we have the ATT window opened up. Now all of these parts are part of the Centroid file. The next step is we're going to be hitting start. And what's going to happen there is it's going to go through and start characterizing, looking at each component. Let's go ahead and start.
So it's identifying these against your parts library that you've got in there?
No, actually what it's doing right now, you'll see, it's looking at each one of these components, and what it's doing is actually finding the component in 3D. It has no idea what the component is. Once it sees the component, once it sees the 3D, it locks in on it. It now knows the length, width, height. It sets up coplanarity automatically, solder automatically, and it does this for SOTs, SOT23s, SOICs. It's actually programming it autonomously right now. Yeah.
Is there a limitation on component size or device that it can go down to?
No, not at all. Quite frankly, as long as it's within the FOV, it's going to be able to program it. So it was that quick. So this board normally takes about 45 minutes to program, maybe 40 minutes to program. This takes under 2 minutes to program. So what we've actually done now is we've actually taught all these devices, and here we have devices that have been taught. So let's go ahead and do a test. That right there is a capacitor. Now the whole thing is, the machine had no clue that there was a capacitor there. It's an 0805 capacitor. But it takes, from those CAD coordinates, it takes the 3D information, it determines, hey, it's a capacitor. It knows length, width, height, coplanarity, solder joint, and it builds that library automatically. So here you can see that the library was built up automatically on its own. So now once again, it is a prototype system, so there's a lot more to be done with it, but it's one of these things where, what do you share with your customers, right? Well, I think it's really important that customers understand when you're buying a machine, right? You're buying a relationship with an organization, okay? I think it's key that you have a very clear insight as to the technology roadmap that company's going to be providing. The sensors that we manufacture, our hardware, we've always had the best hardware out there. The software, we've always had the best software out there as well. It's a good idea, I believe, to show customers where all this is going, because quite frankly, you're starting a relationship, it's going to last 5 to 10 years. With this INTELLI-PRO software, I believe it's a game changer in the industry, and it's my pleasure to show customers where we're going with this.
That's incredible. Yeah, I mean, it really is. It really is. It teaches so fast, and that combined with your tri technology here, it really is, as you say, a game changer. Just to round off the portfolio, Brian, I believe you've got your INTELLI-SYS system, which is really for your smart factory, Industry 4.0 control. Can you tell us a little bit about how that works?
Exactly. INTELLI-SYS, right, that's actually our intelligent factory automation system. What that is, it's kind of an all-encompassing system. We have it's basically a suite of software that we use. There's a suite of software that we use, and we also have connectivity. Connectivity is between not only our AOI systems in our suite of software, but also pick-and-place machines, screen printers, ovens. The whole goal to Industry 4.0, it starts out with connectivity. We need to be able to connect to all the different parts of the SMT line. From there, we need to be able to get data from these machines. There's some data we're going to be able to use, some data we don't use, right? But the whole thing is by taking and connecting to these systems and gathering the data into our intelligent factory automation solution, our goal, and everybody's goal, is to maximize the efficiency of the SMT line, right? Give customers a clear insight into their process and help them build boards with higher quality. So that's what INTELLI-SYS does.
Right. So is bringing in full traceability of the line and of defects or any bottlenecks in the line, basically?
Absolutely. What you can do is, once you have all the data from your SMT line, you can look at your efficiency. You can find out where your weaknesses are, right? Based on that, now we're talking borderline AI, right? Artificial intelligence. The more data that we collect, the more intelligent the system becomes. The whole goal here for the entire industry is really what's called using big data. Big data means that you're collecting data, a lot of data from customers. Actually, the goal is to collect data from customers globally. And from there, all the data you collect will actually maximize your AI capability. The more information that you have, the more the system can actually learn from things. And the whole thing there is, once you know where, once again, your fallbacks are, once you know where you're losing efficiency, that should be glaring to the process. It should be glaring to the manufacturing engineer as to where the process broke down, what needs to be done to maximize your efficiency. Once again, it comes down to data. That's the first step, is getting all the data.
That's obviously the first step, but the second step is obviously trying to make intelligent, actionable data out of that and do it in such a way that the operator can really understand it.
Absolutely, yep, you're absolutely correct. You've done this before, I can tell.
I know. Well, I tell you, it's almost impossible to keep up with the amount of change that's happening in this industry at the moment. It's really exciting, and it's also happening at a time when the industry's on a real high. So it's fantastic. Brian, it's a pleasure as always. Thank you for joining us.
Thank you, sir. Appreciate it.